Let's now take a look at the intermolecular force between polar covalent molecules. So for example, like the molecule HF, which is polar, since fluorine is way more electronegative than hydrogen, the fluorine atom will be delta minus and hydrogen delta plus. Therefore, because of this, the interaction force or the intermolecular force between these molecules will be termed as permanent dipole to permanent dipole attraction forces, or in short, we call it PDPD. And for polar covalent molecule, if we put them in a specific electric field, for example, we put them in a parallel plates where this plate is positive and this plate is negative, you'll find that all the fluorine atoms, which is delta minus, will be oriented in a specific direction as the fluorine atom faces towards the positively charged plate. Finally, polar covalent molecules could also be deflected by actually the presence of a charge rod. Let's now take a look at some examples of polar covalent molecules. The first set we're looking at is Brf and Cl2. Labeled in blue are the boiling points of these compounds. So if you take a look at Br and F, F is way more electronegative than the Br. So therefore, because of that, this will be delta minus, this will be delta plus. The dipole moment will be in this direction. And when you look at Cl2, obviously Cl2 is non-polar. And Cl2 has 34 electrons. So clearly, Brf has a higher boiling point than Cl2 because it can form stronger permanent dipole to permanent dipole attraction forces, while Cl2 forms relatively weaker instantaneous dipole induced dipole attraction forces. Let's now take a look at another molecule, ClBr. In the case of ClBr, its boiling point is 5 degrees Celsius. And in this case, Cl will be more electronegative than your Br. So your Cl will become delta minus, this will be delta plus, and the dipole moment will be in this direction. And I draw a shorter dipole moment because the difference between the electronegativity of F and Br will be wider than the difference in electronegativity between Cl and Br. So therefore, in terms of the magnitude of the permanent dipole for Brf is higher than that of ClBr. Therefore, it forms stronger permanent dipole to permanent dipole attraction forces, hence explaining why its boiling point is higher than that of ClBr, which is polar and which also forms PDPD, but is relatively weaker. Therefore, it's also important to note that in the case of ClBr, the electrons, ClBr has slightly more electrons than your Brf. Finally, let's take a look at the last set of examples, Hbr and Hcl. In both instances, we know that both are polar. So this is delta minus, delta plus. Dipole moment will be shorter. This will be delta minus, delta plus. Dipole moment will be longer because Cl is more electronegative than your Br, and the difference in electronegativity is higher. However, the boiling point of Hbr is significantly higher than the boiling point of HCl. Despite Hbr having a lower permanent dipole, Hbr has a significantly higher number of electrons that leads it to have significantly higher instantaneous dipole to induced dipole. So the overall intermolecular force of Hbr is still stronger than that of HCl, explaining why Hbr has a higher boiling point than HCl despite the fact that it is less polar than HCl.